This is the general process utilized for candidate selection. So you start by reviewing your data. You get all your data from your logs. You look at your reservoir, the reservoir properties. And then the next process is you develop your sonic log. Your acoustic log is the most important tool you utilize to develop geomechanical data. All you need is just to develop your stress profile. So you develop that using GeoSuite. You can get 1D, you can get 3D model of your well. And also an important data you need is the offset data, especially if you don't have your logs. Offset data is very important. Your porosity, your pore pressure is very important in modeling your fracture. Then next, you use mFrac to optimize your frac length. As you can see from the diagram, there's a model or a frac geometry So that's a frac geometry that you can obtain from your frac model. You have your frac length, you can obtain your frac width, and also your frac height. Frac height is very important. Your conductivity is very important. The ratio of your fracture conductivity to the the reservoir permeability is very important. You need to get a value greater than 0, greater than 1. Then once you get that, you optimize your frac treatment. You utilize your production software to predict production using dynamic model. And then from there, your results, you develop or you optimize your lower completion. That's the number of fractures required on that particular well, for example. And then from there, upper completion, you decide, okay, what kind of upper completion do you need? Do you need the size of the tubing? Do you need a DST string? 4.5, 5.5. And after that, you execute the job. You perform the fracture, and then you perform your post-frac analysis, where you do a couple of pressure matching to determine what your actual geometry is for the fracture. So this is the methodology performed during for this paper. So the first process is creating the geomechanical model. What does this include? This includes like analyzing your stresses, generating your stresses, looking at your rock properties, understanding if you have stress barriers. Stress barriers is very important to have in modeling your fracture. So from there, there's a production modeling where you use Prosper or production software to predict your inflow, outflow, the maximum production rate that you can obtain from the well. For example, the optimum or the best flowing pressures that you can produce through the tubing. And then from there, you develop your frac geometry using mFrac, for example, or Gopher, or whatever software you got. There, you optimize your frac geometry. You don't want to, for example, create a fracture of 500 meters when actually you only need 100 meters. If you're getting production of 5 million from 100 meters and you're getting production of 5.1 from 500 meters, why you wasting money pumping too much proppant? The more proppant you pump, the more expensive it is. So you optimize your frac geometry. Then next, production forecast using real data from production, using decline curve analysis, and also for the wells that do not have decline curve analysis, you perform your production forecast using sector model, especially where you don't have decline curve analysis.